Hello friends, welcome back to the data structure tutorial, and today we will be discussing about insertion of a node at the end of the doubly linked list. In the previous video we have discussed about insertion of a node at the beginning of the list, and we know that to insert a new node, first of all we need to create a new node with the help of structure of a node. So here we have already created the structure of a node. So this is our structure of a node. Now we will be creating one function, and that function is insert at the end, which will receive one data, and we have to insert that data at the end of the existing doubly linked list. So the very first task is to create a new node, and we know that how to create a new node. So with the help of creating an object of node class, which is representing your structure of a node whose name is temporary, and a new keyword will allocate the memory. So let's say this is our temporary, and which will get some memory 500, and in the temporaries information field. So as per the structure, this is our information field, this will be our next field, and this will be our previous field. So temporaries information section will carry the data whatever you will receive. Let's say you received the data 5, and the next field and previous field you are making it as null. So you are just creating a independent node to insert at the end of the doubly linked list. Now the condition is, what if there is a no existing list is available? So you have to check whether the existing list available or not. So you will be checking if your start is equals to null. So what it means, you do not have a list. So if you do not have a list, so how you can insert this temporary at the end of the list? So this temporary itself become a starting point. So you have to write start is equals to temporary. So what it means, you are assigning the address of temporary to the start. So this address will be given to the variable start, and this will become your starting point when you do not have a existing list. But what if we have a existing list? Then we have to check into the else part. So let us write that again. So if you have the existing list, so you will be writing here if start is equals to null, then start is equals to temp. This is what we have just completed, and else, now we are in the else part. So here we have a data, here we have represented null. This is what we have created a new node whose name is temporary, and address we have considered as 500. And we are in the else part. It means that we are assuming that we have a existing list. So let's say this is our existing list, is address is 700, the next node is suppose at 700, and the next node is suppose at 200, and it has a certain data. Suppose this is 7, it is 22, and it is carrying 8. It is pointing to 700, so it is connected. It is pointing to 300 previous node, so it will be connected to the previous node. Here suppose it is 200, so it is pointing to the next node because it is 200. It is pointing to the previous node because it pointing to the address 700, the last node representing as a null in the next field, and the previous field of the first node will be also represented as a null, and this is your starting point. Okay, now the condition is, whatever new node you have just created temporary, you want to insert at the end of the list here. Okay, so the very first task is, you cannot directly jump to this address 200. You have to start from the very first pointer, that is start, whose address is 300. So you need to identify the last node of your list. And how do you know that any node is a last node of your list? Just by checking the next field of every node. If it is null, then that is the last node of your list, but you cannot jump directly to the 200. So what we'll do, we'll create another pointer, let's say p, which will start from the starting point. So in the else part, what I'm writing, p is equals to start. I'm writing p equals to start. What it means, the address of start is assigned to p. So this is our p, and we'll check that p's next field is null. No. Then copy this next field in P itself. So how will you write? You will be writing while loop, while check P of next is not is equals to null. P of next is not is equals to null. If this is the case, then P is equals to P of next. P is equals to P of next. Now let us run this case. So P of next is 700, which is not is equals to null. Okay, condition is to come inside. P of next to be copied in P. So what is P of next? 700. You copied into P, so P will be at the next location, that is at the 700. Now again you are checking P of next is null or not. So P of next is not null because it is carrying value 200. Okay, go inside. Copy P of next in P. So P of next is 200. Copy it into the P. So P becomes at 200. Now again check P of next. P of next is null and we don't want null. So it will stop here. So P is representing your end of the list. Okay, and now after this P you want to add your new node, that is temporary. So if you add that, how your list will be looking like? I'll just draw the previous list as it is. So it will be 300, it is 22, it is 200, this is 708, this is 300, this is 700, this is 200, and this is your temporary whose address is 500. Temporary, it has a data 5, the previous field is null, next field is null. I have written this node here, and this is the end which is pointed by P now, and this is your starting point. Okay, so if you add this temporary at the end of the list, so what will happen at this place, what will happen? The address of temporary will be there, so it will be 500, right? So this is connected, so P's next will be 500, that is temporary. So after this you will be writing, like this, that after this loop P of next is equals to temporary. P of next is temporary. So P of next is temporary, that is 500, and temporary's previous should be 200, means P. So temporary's previous is equals to P. Let us do that. So this is the previous of temporary, and what is P? It is 200. So now it is pointing to this node, and you have to just close this else, and this is the closing of your function. So you just inserted a new node temporary at the end of the list. So let us write a code for this. Here we have already implemented a function for insert at beginning. So after this I will be creating another function whose name is void insert at end, and it will also receive one integer data. Fine. So what is the first step? We always create a node. Okay, so call the function create node, which we have already created for the received data. So it will create a new node. Fine. Then you have to check whether the existing list available or not, which we have done already so many times. So you have to just write if start is equals to null, then start is equals to temp, means you do not have any existing list, so temporary itself become your starting point. Else you need to search the end of the list. So for that we have taken new pointer which will be taking the address of starting point, this one P, and then it is moving forward till P of next is not null. So this is the line which we have writing there. So while the condition is traverse P of next not is equals to null till P of next is not is equals to null, what you will be doing? You will be writing P is equals to P of next. Okay, so it will be till the end of your existing list. Once you find the last node which is represented by P, then in that P's next you will be copying your temporary's address. Okay, and then temporary's previous address will be your P. And this is the code for inserting a node at the end of the doubly linked list. So in the next video, we will be writing a code for insertion of a new node at the middle of the list.